Welcome all. Today we're going to dive into how to leverage Highway.Data on top of Highway.Framework. We're going to cover the basic pieces that Highway.Data brings to the table, as well as some recommendations on how to use them. This will start off by going over the patterns and basic structure of Highway.Data, then diving into an application where we can really get started, start leveraging queries, scalars, and commands, move into the more advanced scenarios, and then talk about eager loading, and finally wrap up with what is an IDomain and how do I leverage one. Highway.Data leverages several widely used design patterns, but the central one is unit of work. According to Martin Fowler, the unit of work maintains a list of objects affected by a business transaction and coordinates the writing of those changes and the resolution of concurrency problems, which I think is a great description. One of the key parts that Martin implies is a unit of work is a mechanism for writing changes. This means that it's focused on the C, U, and D, or create, update, and delete of CRUD operations. We'll get to the read in a moment. When leveraging an ORM like Highway.Framework, it does a lot of repetitive work for us, and the unit of work is no exception. Highway.Framework will track the objects we retrieve so that when we're done changing those objects, we can just commit that unit of work. Highway.Framework will at that point translate our object-based changes into SQL statements, commit them to the database inside a transaction, allowing us to almost completely ignore transaction and data persistence concerns within our code. Now let's talk about getting data out of the database. Highway.Framework relies on LINQ, or Language Integrated Query, to define queries and then translate those for us into SQL statements. This means that we no longer have to write SQL statements in our application, we don't have to leverage stored procedures in the database, but what it doesn't mean is that we can ignore the design that goes in around these statements, the SQL that comes out of them, or where they're defined in our application. We need to take the same care with these that we would take with SQL statements embedded into our application. To this purpose, Highway.Data brings a couple more patterns to make this easy and testable. The first of which is a repository pattern. I know, hold on a minute though. It's not the same repository we've all screamed about in the past. Repository is meant to give us a consistent API for retrieving data. Highway.Data repository only has 4 methods, and we're not going to add to them. Using these methods, we're able to query those by leveraging another pattern, the query object pattern. Query object pattern very simply gives us the ability to encapsulate our queries so that the persistent-specific and query-specific concerns are insulated from the person asking for the data. No longer do we embed SQL throughout our application, but we're able to contain it to one object that's both testable and reusable. Now that we've got a general overview of the patterns and structure involved with Highway.Data, let's dive into the code. I've prepared a basic MVC application that we're going to add things to. This basic application is posted at GitHub at the link below. Please feel free to follow along. Before we get started, let's walk through the data project and the domain project that we'll be adding things to here shortly. The data project is where we're going to put our entity framework specific code. This will include our entity type configurations as well as any queries that will be hitting the database. This gives us a nice way of encapsulating those concerns and making sure that no other project besides data has to have an entity framework reference. This will let us encapsulate our data access into one place, and we can unit test all the other places leveraging the interfaces that Highway brings to the table. Now let's take a look at our domain. Our domain for this is going to be a driver's education tracking system. How else could we properly show off Highway? What we have is an instructor that can teach classes, a student that has the ability to take classes, and then of course the classes themselves. We're going to start with the home controller in the index method. This is where we want to return all the courses in the database. Now, before we dive too deep into this, I want to point out that we're going to create the needed objects in the constructor of the controller. This is just for demo purposes. We will later in this video series talk about IOC configuration, so bear with us. As with Highway.Framework, we need a class that tracks our objects and connects to the database. Highway.Data calls this the IData context. It represents the unit of work that we're currently in. This object takes a connection string to the database we're communicating with. Conveniently, I've put this connection string in settings default so that you can leverage it there. The mappings for the objects we're going to use is the other part of the constructor. We just need a class that implements the IMapping configuration interface. This interface has only one method, And that's where we're going to add all of our entity framework mappings that you saw already existed in the data project. These mappings are out-of-the-box entity framework mappings. Highway is just giving us a way to inject them so that we don't have to write the same context over and over. We can leverage an IOC to deliver those into our constructor for us. Now, this interface simply drops in this one method, so let's go ahead and do that now. I'm going to use some of the mappings that we've already defined, but if you'd like to dive deeper into mappings for Entity Framework, you can check out the Entity Framework video that came earlier in this series. The link will be below. Now that we have our mappings class roughly defined, let's go ahead and add in those existing pieces. We want to make sure that our instructor map, our course map, and our student maps are all built into this thing so that we know how to connect our objects to the relational database. As we go through and do this, it's important to keep in mind that this is going to add the objects that it's aware of. If you try and touch something that it's not aware of, but is in the graph, then it will try and infer those through convention. If you don't have a graph connection to something that's already mapped, we will throw an error through Entity Framework saying, hey, that's not here. Now let's make sure we move off our mappings class into our data project because these are specific to our database and we want to keep those concerns nicely segregated. Once we've moved these, we'll just hop back over to the home controller and we'll bring in a using statement that allows us to keep those things clearly separated. Now this gives us our basic construction for a data context. Now that we have a data context, we want to go ahead and create our repository. We'll drop in a field for an iRepository and instantiate the repository with a data context. Now, repository on its constructor takes an iData context, so this could be any data context shipped with Highway. Once we've got the repository instantiated properly, we're going to go in and start using it. So what we need to do next is define that query. That query is going to define our process for going to the database and getting something through an Entity Framework without driving all those details into our controller method. So to do this, I need to be able to instantiate a new query that returns courses. We haven't defined one yet, but I'm going to go ahead and type in the name that we would normally use here. Now these queries, as we said, need to live in the data project. So we're going to go up here and create a folder called queries, and this is just generally where we're going to put these. And inside that folder, we're going to create a query of all courses. Now the all courses query, we've got two possible ways we could do this. We could implement iQuery of T, where T is the return type of courses, or we could implement from a base type that Highway ships out of the box called query of T. This does a lot of the heavy lifting for us. So all we have to do is define a constructor and give it a delegate to call when it's executed. Now the syntax for this is going to be a little off if you're not used to working with deferred execution delegates, but we need a lambda that says C, which represents our context, and returns an as queryable of courses. This is still deferred. It won't execute until we actually need the results of a query, so we haven't broken that really nice feature of Entity Framework. This also gives us the ability to, at some point later, add paging or sorting or filtering beyond the base query. We're going to take this query now that has iQueryable defined, and we're going to leverage it to return a set of courses into index, and then we will take those courses and send them as part of our view model. And I'm going to add a toList call onto this that allows me to enumerate the collection right before it goes in, just to force it to populate the data at that point. Now we're going to go into the About page and we're going to list our veteran instructors. Veteran instructors we've defined, rather arbitrarily, are any instructor that has taught 10 or more courses. So let's go through the same process we did previously. We'll type in a usage of a query that we haven't created yet, and one slight difference. We'll add a parameter on construction that allows us to parameterize our queries and use them over and over. Then we'll take that name, we'll go up to queries, and create a class using that name. And at this point, I have the same question. Do I implement from the interface or do I inherit from the base class? This is fairly simple, so we'll inherit from the base class and have a query that returns instructor. So we'll start by defining context query, giving it a context delegate, and I'll bring in the instructors. Now from here, I have all the power of link at my disposal. So let's pull in the right link, not link dynamic, but link enumerable. And this gives me the ability to say where courses taught, the count is greater than 10. In this case, I'm going to parameterize that, and I'm going to take in an integer of the number of courses that I want to deal with. Now at this point, we have a nice parameterized and reusable query that leverages link. I take those instructors and do the same thing with them. I enumerate them into that view, and I can leverage them when I display them on the screen. Now that we have our home controller returning data in both our index and our about, we need to take a look at a slightly different selection paradigm. In both of our previous examples, we returned a list of data. This is by far the most common selection scenario from a database. But the second most common is the scalar return, or the return of a single value or a single entity out of the database. Highway.Data took that same nomenclature, so where we have queries, we also have scalars, and they both go through the find method. In this case, we want to give the ability for displaying the details about a course. We want our users to both be able to look up a course by ID as well as a course by name. So let's go ahead and create those methods. The first one we're going to be creating is the ability to get details by the course ID. Now by course ID is going to be able to leverage some pieces that are built into Highway just to make it a little easier on you. So I'm going to come in and say, I would like to get a course from the repository, please. Find a new, and I've got this get by ID that's built into Highway.Data. And all I need to tell it is the type of the ID, which in this case is an integer, and the thing that I'm selecting, which in this case is a course. And I give it the course ID, and at that point, my selection is done. Now this leverages a couple of things, and I want to make sure that you don't think there's hidden magic here. Courses are entities. Our core entity has this identifiable interface on it that takes a type of the identity. This could be a GUID, a long, a string, you name it. As long as it's a singular property, this will work just fine for you. So for most of your objects, you'll want to do this because it gives you a lot of benefits. When we get into the video series on our MVC stuff, we'll actually talk about how this structure gives you the ability to very quickly ramp up a web API endpoint or a REST endpoint without a lot of plumbing work on your part. But now that I have this, I'm just going to return a view that takes in our course, and away we go. Now, the slightly less pre-built version of this is when I want to return details by the name of our course. In this case, I'm going to take in a course name, and I have to do a little bit more plumbing here. It's going to look very similar, where I'm going to ask the repository to find something for me. But this find is going to be something that doesn't exist yet, which is going to be course by name. And I'm going to pass it in the course name so that we can use a parameterized query. And I'm going to return the result of that to the screen. The exact same screen, just slightly different. Now course by name doesn't exist, so let's come up here and create it. We'll create a class called course by name, and we're faced with the same choice we made on query. I could either implement iScalar, of course, and I could implement this by hand. If that was an advanced scenario, we could do that. This one's fairly simple, so we're going to take the base object because it does some stuff for us. Same thing as before, I'm going to create a constructor that gives me a context query. The only difference about this context query is that instead of returning the full list of things, I want to return just one. So I can use any one of the aggregate functions, single or default, single, first or default, based on the behavior that I want. I can return these as long as I only have one thing that matches it. So in this case, I'm going to add a string property to my constructor, and then write a query that only returns one thing. This gives me the nice ability to return a singular instance instead of having to have first or defaults in all my using code. This gives the person requesting the data the ability to say, am I expecting one thing or more than one thing, without knowing the intricate details of how that maps into the ORM. Now that we have selection of both a list and a single entity, we need to talk about execution. Execution being the paradigm that we fire something off to the database, but we're not going to be returning a lot of objects from it. We're not even going to return a single value from it. This would be case in point of deleting something, which is the example we're going to use. I want to give people the ability to delete an object. So I'll take an action result here and we'll create up a delete for course. We'll take in the course ID that we're going to be deleting and we will ask our repository to go execute a delete. Now the execute method takes in an I command. We're going to create a new command called delete course and we'll give it a course ID as a constructor parameter. And then we will return a redirect to our index action because this one's not going to return anything to its view. Inside our queries, we're going to come up here and create a class for deleting our course. Now that we've got this, we're faced with the same choice we had earlier with Scalars and queries, where I can take I command from Highway.Data, or I can take the base object. This is the simple case, so we'll take the base object. And at this point, I still set a context query. And in this query, I don't need to execute anything for a return. I simply need to go delete a course. So I'm going to go get the course that I need. This is the ORM paradigm of you can't do something you don't know about. So the object has to be in memory and tracked before we can modify it. So what we're going to do is create a very simple delete here that pulls back something matched by ID to the course ID that we pass in. We'll add that as a constructor parameter. Okay? And then we will ask the context to remove that course, and then we will commit that unit of work. This allows us to have a nice, cleanly concise unit of work for this delete, where it fires into the repository and is immediately committed. That concludes our basic usage. We want to dive into a couple of advanced topics now to give you a well-rounded grasp of what Highway brings to the table and the pieces that you can leverage. Highway has a concept built in called the Advanced Query, Command, and Scalar. These sound daunting, but they're actually very easy. The first of which is readily apparent. The delete, having to go look things up, is a problem. So what we can do is convert that to firing a SQL statement. If we go to definition on delete course, we have to go get an object from the database just to delete it. And a lot of people don't like the fetch and remove paradigm for this, and I'm one of them. So let's go ahead and make this guy an advanced command. Now, the easy part about this is I can just say that this is now an advanced command. And you can see that it still works. What this does, however, is gives me some additional properties or additional methods on context in which I can execute a SQL command, which in our case allows me to give it a nice SQL statement. This could be executing a stored proc. This could be a lot of things, where I say delete from, and I give it the name of our table, which in this case is courses, where ID equals, and I can either parameterize this thing with @ID and give it a new array of database parameters. I'm going to do this. And I'm going to say this is a new SQL parameter. The name of the parameter is ID, and its value is the course ID I just passed in. This gives me a nice parameterized SQL statement that I can execute. I don't need to save it. I simply have go execute this thing for me, please. Okay? That's the basic for delete course. So we're going to go ahead and keep that. This gives me a nice advanced query where I can take advantage of any legacy stored procs I may have, some long-running queries. I can fire these things off and have some control, but keep in mind that this has now bound me to my persistence layer. If the name of that table changes or if I modify the ID property, this will now be more fragile. It's with great power comes great responsibility, or insert your cliche here. The next one we want to talk about is projection. For our list of courses in our index page, this all course query, we don't really need the entire course object. So let's just get back the names of the courses. I could do this by changing this to a string, but there's another piece inside Highway.Data that allows me to say I'm selecting on course, but I'm returning a string. You'll notice context query now doesn't compile. This actually is because we've split the paradigm into a selector, which is where my base filters would live, as well as my selection criteria for my application, and a projector. This projector gives me the ability to have my courses IEnumerable and project off of that. I can use select and say go select name and project a string if I use the right link. And this would project out a set of strings. Now I could also then to list and select out a view model class or something like that. This gives me the ability to project not only values but also entirely different types that aren't mapped in the database off of a query. It's a very powerful selection criteria and it gives me a nice flexibility point. This is built into Highway. The other advanced query paradigm is normally eager loading. Now eager loading means that for, let's say, my course details, I also want to load the instructor. I will go into course by name, and inside this I want to bring in the instructor with it. Now we by default turn off lazy loading because it can cause n+1 and n² selection problems inside your query if you're not careful. What we do to offset that is leverage eager loading. Eager loading means that when I define this query, I'm going to define that it includes a related object. And when that is selected from the database, it will automatically select with that join for the other table and materialize both objects at the same time. This include gives me the ability to define the graph that I would like to bring with my query. Now, another one of those things that you want to use very carefully because your queries can get very large if you're doing these at multiple depths or multiple widths. So the more includes you get, the more times you want to question whether, am I doing the right thing? I've noticed personally that anytime I get more than 4 included objects, my method is probably doing too many things at once. That takes care of the advanced walkthrough. You have that same ability to create advanced queries, scalars, and commands, leverage SQL or executions. What we want to talk about now is the ability to protect yourself with some guardrails. We want to put a divider in between the highway just to make sure that in large applications we're not stepping all over ourselves. So in a lot of the advanced scenarios you'll see in Highway for event interception or creation, our factories take something called an IDomain. Now up till now we've avoided this topic, but I think it's a good time to jump into it. An IDomain would affect the repository we would create. We would come in here and say, I want to create a domain repository of, let's say, the driver's ed domain. Now, our driver's ed domain would take in an IDomain context for the driver's ed context as well as the domain that we're creating. So let's go ahead and do that now. We're going to come over here to our data side and we're going to define our domain. Now, a domain is an implementation of the domain-driven design concept of a bounded context. So when we bring in our driver's ed domain, we're going to implement from IDomain in Highway.Data. Now, IDomain has 4 properties. The 4 things that define what you can talk to and what you can touch. The first one being the connection string. Now, obviously, our connection string we've been passing in through constructor injection, so let's continue to do that. And then the mappings class. Now, our mappings class isn't going to change much, so let me go ahead and initialize that property, and we can initialize mappings as well. This gives me my driver's ed mappings directly, and my context configuration. Now, by default, the context configuration is the default context configuration out of Highway. This turns off lazy loading and proxy generation. If you have a good reason you really want those things on, this is where you would implement the iContext configuration and you would set it in here and you have that extensibility. This also gives us the ability to set events. There's an entire event interception paradigm inside Highway that allows you to hijack execution before a save, after a save, before a query, scalar, or command executes, and after they execute. This gives us auditability, automatic logging, user control, soft deleting. I mean, it goes on and on, but it is a very deep in the guts kind of hijacking. Basically what you're doing is AOP, or aspect-oriented programming, where you're taking a cross-cutting concern and applying it without the person writing the code that uses it knowing about it. It has pros and cons, and we're not going to dive into all of those right now, but I wanted to let you know that it was there. There'll be another video in a later series talking specifically about how to do that. But in this case, we're just going to create a list of IInterceptor. It's empty, basically meaning we have no events that we need. Now this defines the driver's ed domain. These are the only things that we can talk to. If this was a larger application, what we would then be able to do is come in and say, I want a new domain data context for the driver ed domain. And it takes in an additional parameter now, where instead of taking in mappings and connection string, because we already have those, we're just going to give it the driver's ed domain, and because we passed it in through constructor injection, we'll give it a connection string for the domain to create itself from. Then we pass in our context to our repository, just like we normally would, but we also want to pass in an instance of domain. The reason that we need to pass in the instance here is because those event interceptors get registered slightly differently. So what we'll do is extract that out just a little bit and send it in to the driver's ed here. Now this context would work exactly like the rest of them. There's no changes on selection, querying, saving. All this does is put some bounds around how you execute against things. If I tried to write to the accounting part of the system from inside driver's ed, it would tell me that I was trying to touch an entity that was not mapped as part of the current domain. This would be a red flag as a programmer to go, oh, I'm touching someone else's data that I don't control. This is for segmenting very large applications, but you may see the need for doing this. Now that we've gone from our basic structure and patterns through our usages into our advanced topics like SQL statements inside your commands, let's talk about how to test with Highway.Data. One of the big problems with Entity Framework is that it relies heavily on concrete implementations. This makes it very hard to test. Test-driven development being a very core value that the designers of Highway.Data hold, we wanted to make sure that all of our interfaces were extensible and mockable, that we never relied on concrete. It gives us a lot of layers that we can test things at, and it draws up some questions about when do I use each layer. So let's start from the top layer and move our way down. In this case, I need to create a constructor that would most likely already be here for my IOC to leverage, which is injecting my repository dependency into my controller. We're going to do this so that we can start testing against it. As I said earlier, the constructor piece that we built here was simply for demonstration. Your more likely way of injecting this would be through a constructor that passes in your I repository. Now let's go over here to our home controller tests. And we have a new method in our home controller that we're going to be writing a test for. So let's go ahead and do that here. I'm going to create up a test, and this test is going to be for details by name should get data from the repository. Now anything that uses a repository is going to write a test in this same function that we're about to, where I'm going to mock repository and simply return the right data from a query. I'm not testing the query, I want to test my business logic in isolation. We'll get to testing queries here in just a moment. So the first thing I'm going to need is a mock repository. I'm going to use RhinoMocks. Feel free to inject any of your preferred mocking frameworks here. I prefer RhinoMocks, so that's what we're going to use. Now for my repository, I can tell it to expect a call to find in which the argument is of type course by name. I need to add a reference to data because it's not there otherwise. And then I'm going to tell it, when you get that call, I'd like you to return a new course, if I could type it correctly right now, and add a reference to domain with a name of testing. Now this gives me the repository set up to get that call. What I want to do now is the target of my test is my home controller, so I'm going to pass in my repository to my home controller. And then I'm going to invoke on my target the method that I was expecting, which is details and a string. Now what I want to do at this point is make sure that I verify all the expectations that were on my repository. And I can go ahead and run this guy. And when it sets up and runs, what you'll see when I bring my tests on to the screen is that I now have a passing test against a mock for the repository. This gives me a nice way of testing out things that leverage the repository without giving them the intimate details of how the repository functions. Now for simple selection, this works very well, but mocking against a repository for a complex interaction where it's adding values, committing those values, gets rather onerous. So we've given another way of doing this. The other way of doing this, I'm going to write another test that looks very similar to this, so I'm going to use copy-paste inheritance. And we're going to give this a second way. Now the second way is actually avoiding the use of a mock altogether. The repository that we're going to use is actually going to be a real repository. And we're going to instantiate it with an in-memory data context. The in-memory data context functions just like a real in-memory database. And then on the repository, I would say context add. I would give it a new course with the name that I was expecting. And then down here, I can assert that result is not null. And when I run this guy, I get a passing test. So I have two different paradigms. I can use either a mock or I can use the in-memory database. The in-memory database gives me the nice ability of modifying objects in larger graphs without having a huge mock setup. I simply create the in-memory context, add things to it, and then at the end of the scope, it's disposed of so that I don't have a heavy performance cost to my unit tests. I do, however, lose the assertion of behavior ability. Now let's talk about unit testing queries, because query testing is very important. We have some queries that do some filtering, and because we've been using course by name, let's go ahead and do this. So, course by name should filter on name. Sounds pretty easy, right? There are also two paradigms for doing this. We're going to do the first one, which is our mock paradigm. So I need a context where I create a mock of IData context. And I tell this mock that it should expect a call to as queryable for course. Now when it does, it should return a new list of course with two objects in it. Two objects is your bare minimum for testing something. You want to give it something that matches, like our testing, and then you want to give it something that doesn't match. This gives us the nice ability to make sure that our filter is working the way we expect it. So I'm going to create an object here that says should not match. Okay? Now, to get rid of the highlighting here, we're going to use an awesome piece of link called as queryable. As queryable turns any flat enumerable into a queryable and gives me the ability to inject them into tests very quickly. Now that I have this context, all I need to say is give me my results of a new course by name query for testing, and then tell it to execute that query against the context given. And when I do this, I should be able to get back and say that the results assert that the result is not null, So it found one and only one. And I can also say assert r equal result.name is testing. Now by doing this, I have a mock in place that returns those objects, and I can run it. And as it runs, you'll notice that I'll get a nice green arrow right over here. My test passes. Now this is the mock version. Let's talk about the in-memory version. So we're going to copy paste inheritance this guy as well, and we're going to write the second way of doing this. The second way, very much like our second way for our repository, leverages the in-memory data context, and instead of bringing back two different courses, I'm actually going to add two different courses to our database. So here I'm going to say context.add our new course that matches, as well as adding the course that doesn't match. And by executing this, I now have a passing test that uses my in-memory database rather than a stub. For modification style things where the mock would get very onerous, this is the approach that you'll want to use. Thanks everybody for watching, and keep your eyes here for more video tutorials for Highway Framework.